Good evening. Welcome back to my lectures on space, time, and motion for Physics 151 and Physics 201. You might recall that we've been talking about Galileo's dialogues concerning two new sciences. We're in chapter 8 in a student's guide. This is a chapter on naturally accelerated motion. Galileo has introduced the idea of uniformly accelerated motion, and he defined what he meant by that, and then he's fielding various objections that Sagredo and Simplicio have. We got to the point where it seemed like they were conceding that his theory might have some truth to it, but then they began to debate the reason why dropped objects would undergo naturally accelerated motion in just this way. Galileo, it seems, grows tired of this, and so Salviati says, we are in the middle of page 112, he says, regarding all these ideas that are being thrown around, all these fantasies and others too ought to be examined, but it is not really worthwhile. At present, it is the purpose of our author merely to investigate and to demonstrate some of the properties of accelerated motion, whatever the cause of this acceleration may be, meaning thereby a motion such that the momentum of its velocity goes on increasing after departure from rest, in simple proportion to the time, which is the same as saying that in equal time intervals the body receives equal increments of velocity. Now, I just want to point out a couple of things here. Notice, first of all, that he is, as I mentioned in my last lecture, interested primarily in kinematics rather than dynamics. That is, he's interested in simply trying to describe the motion of falling objects without attributing a particular cause to that. That's something that might be discussed on a later date, but he's not interested in discussing that right now. Secondly, notice that this is in 1620s, and there is not a settled language yet for motion. So he at one point says the momentum of its velocity. It's not quite clear what he means by that, but it seems like he's saying simply what we would refer to as velocity. He says that, and this is his definition of uniformly accelerated motion, it is motion such that its velocity increases in proportion to the time. That is, it gains equal increments of speed during equal increments of time. Now, having said that, Sagredo brings up a counter-argument. He says, so far as I see at present, the definition might have been put a little more clearly, perhaps without changing the fundamental idea. So now what Sagredo is going to do is offer a counter-theory. He says, namely, uniformly accelerated motion is such that its speed increases in proportion to the space traversed, so that, for example, the speed acquired by a body in falling 4 cubits would be double that acquired in falling 2 cubits, and this latter speed would be double that acquired in the first cubit. So he's basically saying that whereas you are saying, Galileo, or Salviati speaking for Galileo, where you're saying that a falling body acquires equal increments of speed in equal increments of time, why not say just as simply that an object acquires equal increments of speed in equal increments of distance? That is, if something falls for 1 cubit, it will acquire some speed by the end of that fall. If it falls 2 cubits, it will have twice that speed. If it falls 3 cubits, it would have 3 times that speed, and so on. So the speed is proportional to the distance, not the time. That's a counter theory that Sagredo is bringing forward, thinking that would be just as simple. Now, how does Salviati respond to this? He says, it is very comforting to me to have had such a companion in error. And moreover, let me tell you that your proposition seems so highly probable that our author himself admitted when I advanced this opinion to him, that he had for some time shared the same fallacy. But what most surprised me was to see two propositions so inherently probable that they commanded the assent of everyone to whom they were presented, proven in a few simple words to be not only false, but impossible. So in other words, Salviati is saying they seem to be equivalent statements, equivalent theories, that the speed is proportional to time and the speed is proportional to distance. But in fact, they're not, and one is a better theory than the other. And the one that Sagredo is bringing up is the fallacious theory. It's not correct. And here's the reason that he gives. If you look at my sketchbook for a moment. So remember, the idea that Salviati has is that equal speeds are acquired in equal increments of time. And Sagredo's theory is instead that equal increments of speed are instead acquired in equal increments of distance of fall. Now, how does Salviati address this and show that it cannot be correct? Well, he argues in the following way, and this is on the top of page 113. Oh, and by the way, let me say one other thing on the bottom of page 112. After Sagredo proposes this theory, Salviati says that it's not correct. Simplicio chimes in at the bottom and says, I am one of those who accept the proposition and believe that a falling body acquires, in its descent, its velocity increasing in proportion to space, and so on. So Simplicio basically chimes in and says, I'm on Sagredo's side. I think he is right. Okay, so now, how does Salviati address this? He says, suppose you have an object that you drop and it falls a distance of 4 feet. 4 feet, okay? In so doing, it is going to acquire some speed. Okay, so that's the velocity it has after falling 4 feet. Okay, now let's suppose you have another object that you drop and instead it falls 8 feet. Okay, this is 8 feet. Now, if Sagredo's theory is correct, then in falling twice as far, it will have acquired twice as much speed. So that would be the velocity that it has acquired after it has fallen 8 feet. And he's claiming, if Sagredo is right, that that would be 2 times the velocity that the object acquired when it fell only 4 feet. Okay, so let's take Sagredo's theory seriously. What does this imply? Well, what Salviati points out is that if it has twice the speed as the first case, and it's gone twice the distance as the first case, then it must have reached the bottom in the exact same amount of time. So if it travels twice the distance, but, as he claims, it has twice the speed, then, so if that happens, then the time of descent of 8 feet must be the same as the time of descent of a ball falling 4 feet. Because after all, it's going twice as far, but it's going twice as fast. So it would imply it takes the exact same amount of time. And he argues it's absurd to think that a ball falls 8 feet and 4 feet in the same amount of time. So that cannot be right. Therefore, he says, Sagredo's theory is in error. Now, this is an interesting argument because Salviati is onto something here, but there's a problem with this. And this is something that you don't have to work out, but if you'd care to, in exercise 8.3, we take this theory seriously and we show that what Galileo is claiming here and what Salviati is claiming here is not quite right. Sagredo's theory does not imply that they will fall 2 different distances in the same amount of time. That doesn't mean Sagredo's theory is correct. It is in fact wrong, but it's wrong for slightly different reasons. So this is one of these cases where Galileo is kind of onto something. He knows Sagredo's theory isn't right, but the rationale he gives, the counter-argument, it doesn't really hold water if you look at it closely. And again, if you're interested, you can work through exercise 8.3. Okay. Now, it's interesting, though. They go on, and what do they say? Well, in any case, on page 113, Sagredo responds after Salviati's counterargument, and Sagredo says, you present these recondite matters, these challenging and difficult matters, with too much evidence and ease. This great facility makes them less appreciated than they would be had they been presented in a more abstruse or complicated, difficult to follow manner. For in my opinion, people esteem more lightly that knowledge which they acquire with so little labor than that acquired through long and obscure discussion. So notice what's happening here is that, remember, Galileo wrote this dialogue, and Salviati is speaking for Galileo, and he just had Salviati tear down an opposing theory and give an explanation for why the opposing theory is wrong. And then Sagredo, one of the characters in this play that Galileo is writing, comes back and says, oh, you are so brilliant. So it's kind of a way of Galileo complimenting himself. And I think this kind of demeanor that Galileo has in some of his writings is what caused him some of his trouble. In any case, he goes on in the following paragraph, Salviati speaking, and this is a bit of a psychological analysis of perhaps why people are so opposed to his theories. He says, if those who demonstrate with brevity and clearness the fallacy of many popular beliefs were treated with contempt instead of gratitude, the injury would be quite bearable. But on the other hand, it is very unpleasant and annoying to see men who claim to be peers of anyone in a certain field of study take for granted certain conclusions which later are quickly and easily shown by another to be false. I do not describe such a feeling as one of envy, which usually degenerates into hatred and anger against those who discover such fallacies. I would call it a strong desire to maintain old errors, rather than accept newly discovered truths. This desire at times induces them to unite against these truths, although at heart believing in them, merely for the purpose of lowering the esteem in which certain others are held by the unthinking crowd. Indeed, I have heard from our academician, the person I've read, many such fallacies held as true, but easily refutable. Some of these I have in mind. So here, Galileo is really taking a dig at his opponents who are criticizing his theories, and he's saying, oftentimes they know my theories are in fact right, but they don't want to give me credit for them because they want to lower the esteem that the unthinking crowds have of me. In the next lecture, and my final lecture on Chapter 8, I'll talk a bit more about two final experiments that Galileo describes that are related to falling objects.